So now we're going to look at basic transformations of a sine graph and a cosine graph and what they look like. And one of the things that we're going to do here is we are going to graph these as well. The question itself just says determine the amplitude. But for each of these, we're also going to graph them. Now, in this case, okay, first of all, in the end, for sine and for cos, we're going to look at all four transformations. If you go from left to right, can you see that A and B would be stretches and compressions? And C and D would be translations. Can you see that A being outside of the function would be vertical stretches and compressions? So if we use what we know from transformations, when I see in A y equals 2/3 sine of x, can you see that you would have a vertical compression? All of your y values are going to get multiplied by 2/3. Now our original sine graph, this is why I got you to draw them. If I would draw my original sine graph, I'd have 2 pi, pi, pi over 2, 3 pi over 2, going up to 1, down to -1. Take my axes family. There's my original sine graph. What's going to happen to these points if I do a vertical compression by 2/3? So for an A, I can still have these four sections, pi over 2 and 3 pi over 2. They're not going to change because they're x values. Can you see where your y values are 0? They're not going to change because you'd be multiplying your y value by 2/3, right? But now, instead of having pi over 2 comma 1, I now have pi over 2 comma 2/3. And same thing here. I have three pi over 2 comma 2/3. And when we go to graph this, it has the same shape as before. It's just been compressed a little bit. Now remember, this question is saying determine the amplitude. The amplitude is the distance from the maximum to the center line, or the distance from a minimum to the center line. Well, how far is that black distance? The amplitude is now 2/3. In part B, whoops, sorry, there we go. No, that's not where I wanted to go. There we go, part A. In part B, we want to graph y equals -4 cos x. Okay, using our transformations, can you see that we have a vertical reflection and a vertical stretch? Our transformations would tell us to multiply all our y values by -4. So off to the side, just like you had to know your parent graphs for x squared, x cubed, square root of x, you now have to be able to quickly graph sine of x, cos of x, and tan of x. Your period is 2 pi, so we split it into 4 equal sections to show our quadrants, and our regular cos graph goes from 1 to -1. Now you're going to hear me talking a lot about a cos graph starts from a maximum, and a sine graph starts in the middle. Because your cos graph starts at a maximum, then goes maximum, middle, minimum, middle, maximum. Now, if that's my regular cos graph, when I go to graph y equals -4 cos of x, well, here's 2 pi. Split it into 4 equal sections. If I multiply y by -4, does it make sense that where it's 0 is not going to change? But instead of having a maximum at 1, if I multiply by -4, my starting point is now going to be at -4. And at pi, where it's -1, if I multiply that one by -4, this becomes my new graph. Again, what's your amplitude? Your amplitude is your distance from a maximum or a minimum to your center line. Can you see that the amplitude is 4? And we're going to be using this as a shortcut for graphing sine and cosine. Because the amplitude was normally 1, any kind of stretch or compression in front is going to change your amplitude. And so whatever number is in front, whatever is your A value, you have to have some kind of smart memorization technique here. Somehow have to remember that the A value is connected to amplitude. I don't know how you're going to do that. But if you have some sort of memorization technique that works, that A for amplitude, perfect. So your A value is always going to affect your amplitude. So here we see a 2/3. You can say right away, my amplitude is 2/3. Here we have a -4. Your amplitude is always positive. Despite being reflected over the distance, because amplitude is a distance from a maximum or minimum to the center line, and distances are always positive, our amplitude for the second one is 4, despite there being a -4 in front. So that's one thing you have to make sure that you're not just seeing A as amplitude. Oh, I gave you away my memorization technique. If there's a -4 out front, your amplitude is still +4. Okay, questions to practice. 3A and B, 4, 5, and 9.